Hi everyone. It's a great pleasure to see so many people in the morning, because the morning presentation is always very important, because people who come here come to listen to you. In the afternoon some people may come for different reasons, but in the morning you all came to listen to me. Thank you very much indeed. I am Vadim, and we'll talk about what continuous integration is, what automated testing is, and what do we have to do. A few words about myself. Vadim. It's not a misprint. This is what they wrote in my passport. This is the Belarusian name. I am from Belarus. I work in the city of Minsk. And this is the correct spelling of my name in Belarusian. So ComAQA is our company, and we have a lot of useful information. You can go to our website if you are interested. What are we going to talk about? We shall start about CI, continuous integration, what it is. Briefly, it's a long subject, we shall be brief. Then we'll talk about typical steps, what automation specialists have to do, step by step. Why? I want you, who is not very well aware of the process, who are at the beginning of your way, to realize what we do, what the result is. Some steps can be done earlier, some steps could be reached at the end of the journey, but you can think about it beforehand. That is the key information today, as I believe. I am not going to focus on technical aspects. It's not a presentation about Jenkins setup, no. It's more about processes. We shall talk about general, typical, potential difficulties and issues, how to avoid them, how to bypass them. We'll talk about some extra things, and in the end we shall summarize to structurize your information so that you are ready for continuous integration in your company. Now let's quickly and interactively find out who knows about continuous integration. Raise your hands. Excellent, perfect. Now, who already uses it? Oh, almost everyone who knows about it. Perfect. And I would like to spend two slides on explanation, but you know. However, some people are not well aware of the fact, but the practice of continuous integration is a practice of extreme development, extreme programming. It's about development. For automation specialists, it's additional product. You can take part in it or not take part in it. It's for developers. It means that the developers on a regular basis, several times a day, deliver to the general repository, which is always workable. And when developers integrate their code there in order to check its workability, what do they have to do? They have to test the code to be sure that if I change the presentation, I am not going to break what was done before. It's not about the fact that the programmer is bad. Maybe you made an error, maybe you deleted something by mistake, maybe some changes are not compatible to the previous work. It's a teamwork, and it means that many people do different things and they should not interfere with each other. So you have to test your code thoroughly. So this practice came from extreme programming. If we want to test the code, it means that the code is tested by unit testing, by tests which engineers, automation engineers, use. So you develop, they test. But in the modern world, simple unit testing is not sufficient, and unit test will not guarantee the quality of the product. Accordingly, CI was evolving, and we included integration tests to see that all the modules, all the units can be integrated well, and UI testing is going on. They also take part. We are going to tell more in greater detail later, because they are standing a bit aside, but I'll tell you later about it. Why do we need the process? Yes, they continuously supply the code, check the code. So what? I want to quote an important guy, Martin Fowler. I am sure you know about him. He stressed that continuous integration never gets you rid of bugs, but it makes them easily to find and remove, because at each integration, each change is tested. If the change shows some defect, you disclose them this defect immediately and correct it immediately. Otherwise, you can wait for a week, and then in a week a lot of changes will accumulate. But if you check and test every granular unit, you will kill all the bugs one by one. So we have integrations every day. Each developer every day integrates and accordingly tests his codes. And the whole cycle of testing should take no more than 10 minutes. You developed, you merged, and in 10 minutes you have to see it works, we go on. It doesn't work, we roll back. If it's serious, or if an error is a minor one, you can correct it right away and retest. And that's what you do every day, several times a day. So the benefit for the developer is quite clear, but we are talking about automation. Let's look at what kind of benefits automation engineers can have. Let me view this from another angle. If we don't take part in continuous integration, what kind of bad things may occur? First of all, if we are not part of the process, then we have to rely on someone else. We become dependent on someone, on a specific person. For example, in our team, you are going to be responsible for tests. He is the main test expert. He builds environments. He knows how to run tests. It's all right, but not always. In the worst case, if Vasya leaves the company, if he is sick, then you have no test. Then he may forget something. Well, if he skipped one day, it's all right, but if 2-3 days, then you may have real problems. The second issue is a lack of automated test data environment preparation. You need some data for testing. Ideal automatic tests should be atomic and granular. If you add something, then you have to use some data to test your application. It's a very bad practice when different tests use one set of data. So those tests cannot be run in parallel. For example, if one test is about data writing, the other is about data editing, and the third one about data deletion. So you cannot do it simultaneously. Accordingly, you must have 3 sets of data for each of the tests. Where do you have to take the data from? You have to prepare it beforehand, because when you deploy an application, it's empty. There are no data. There is no data. But your data has to be added. In the best way, it should be done automatically. You have to think about it beforehand. Issue 3. Let's come back to parallelism. If you don't test regularly, we have, for example, 3,000 regression tests, and we run them once a week. But in a week, you can have 10, sometimes 100 tests, and you run them locally first. They work in our environment, but we don't check their integration with other tests, with other software units. How are they going to work in parallel? Are there any conflicts, incompatibilities? Locally it works. We run regression test once a week, and we see 50 issues, but locally it works. In the integrated environment it doesn't work, so we have to think about it. And issue 4 is that without generally running auto test, we don't see the general trend. No general tests, health, status check. So any automation specialist cannot realize what is happening here in this chart. Why so many tests here, so few tests here, why different number of tests, different number of issues. It's a typical situation if you run your tests once a week, because you never can tell what is going to happen in 2 or 3 days. So we need continuous integration. Is there anything who disagrees? No. Let's talk now about the typical way of doing it. I want to stress that there is no right way. There are different ways, and some ways are quite good for you right now, and some of them which do not fit you. There is no right way or wrong way. There is your way which suits you, which fits you now. For example, we need continuous integration, automatic tests. The first thing to do is to automate, build and run. Okay, so what kind of hints can you suggest? What shall we do first and we need a CI server, continuous integration server. For example, we have an environment, we are testing something somewhere. We don't need to tune and customize environment. We need a server to automate, build and run. I don't want to go into detail how to choose the servers. In each case, you will see which tool is better for you. I had a separate presentation a few years ago, comparative analysis of the most popular tools for continuous integration, where I described all benefits and advantages and disadvantages of each particular server. The first question is, are we going to use the same CI server as the developers use, or can we use some other server? For example, if they use CMS and we use Java, there is no clear answer to this question. If you want full-scale integration into the process, if you want to reach continuous deployment even, then it's better to use the same CI server. It will be easy for you to integrate into the process of application build, unit test, run. It's easier for you to see the results. Unit test, integration test, UI test. It's easier to integrate in the process if you use the same CI server, but actually it's not always the case. It's not mandatory to use the same server. We can run automatic tests every day. It's enough to run it at midnight when nobody does anything, when all other stages have been completed. So, of course, you can use an independent server. And very often this is the case in many projects when you don't have close integration. And it works. The next point is licensing. CI servers include open code servers, freeware, conditionally freeware, paid, conditionally paid, different kinds of servers, and you have to see if you have enough facilities and resources, if they are free. Do you actually need paid resources or not? Jenkins is one of the most popular. TeamCity, well, there are different variations there. You can get limited free license. If it's not sufficient, you can pay some money and use additional features for automation. Bamboo is for you if you need it, if you need close integration to Gyro, then perhaps Bamboo. So please look carefully at what paid services provide, or use free versions wherever possible. VCS support. You keep your tests and the result of your tests in a certain repository with version control. Your build in CI server requires the call of one command line. It doesn't matter what is the version of your control. You can take the code out of the repository, but when you have direct integration, it's much easier. It's easier to set up, to customize. For example, you have chosen the tool, installed it, tuned it, deployed it. What is next? We set up a job. The job which would run your tests on schedule at midnight, for example. midnight, full moon, we run tests, and we come to a question, well, we see that it would be better to generate our test data. We redeployed it, redeployed, then you have to retest. Do we have to use the same data set or take another data set? And there are three variations here where to take test data from. You can add data within tests before fixtures. Use standard text fixtures that you have in any test framework before the test we generate. After the test we delete the data. Why USB? Do you realize? The key word is on the go. We create test data on the go, on the fly. There are some drawbacks here. For example, well, first of all, the testing time becomes longer. Before each test, before each suite, we add data. On the fly, we can use UI, which is not a good practice at all because it extends your time significantly and the general time becomes longer. And in the end, you have to clean the data. Data cleanup can be an issue as well. For example, we added data, created data, ran tests, stopped or failed in the middle, the application stopped talking to you, but the data stays there. It is not deleted.
It couldn't physically run because everything was down. So the cleanup of this data is a problem, or can become a problem. Why? Because you can have a lot of such data accumulated, you can contaminate your database, and in the test environment, usually things are not as powerful, not as good, so the contamination of your database may become a real issue. Also, when it comes to data that is prepared during the process, for example, we have a process that creates, that does all the relevant checkups. If you don't purge the results of these tests, you may have a problem, because if you do it once, if you do it twice, 3 times, and so on and so forth, you may have a lot of this garbage, a lot of this junk accumulated over time. So at the next stage, very often when people begin to see these problems, these issues, people decide to add data using some scripts. For example, before the run, we create a data set. We use it once during the test, and we just do it that way instead of adding data directly to the database. This method has its own shortcomings. You have to roll back this data somehow, and it's not always easy to do, because quite often data is added to the database as a single table. It is added, if it's added correctly, it is added to a large number of different tables with dependencies, and if, let's say, we change the logic of hidden data and your script doesn't take this into account, you may run into a lot of issues in rolling back these changes. You increase the probability of an error, because let's face it, we're not experts in databases, because we were not the creators and developers of the database. Of course, we can read the specifications, but we may not know how the logic of running this database and operating this database is structured. So we increase the probability of errors. The same problem applies to accumulating junk data. We run these tests create additional data, and we create additional users or accounts, And then, if we don't explicitly delete this new user that we created during the test, then this user remains, and that's not very good, because we may end up in a situation where we have a lot of users that are not real, that were just created during the testing, and that's not very good. And of course, direct manipulations with a database always increases the risk of breaking things down. We think that we add a scenario to one table, but we may implicitly affect a lot of other tables, and that may break things down. So the next logical step is to use some predefined database that we sometimes call mock database. So in advance, we prepare a database that has all the necessary data. For each deploy, we use this database, and then we roll it back. That allows us to get rid of this problem of junk accumulation, but we still have potential problems. So the problem is that you need to talk to the designers, to the developers. Well, that may not seem like a very big deal to you, but still that requires you to take an additional step. You have to actually talk to the database designers, developers, and explain to them what you're going to do and so on. Originally, when you have to create this database for the first time, you have to invest a lot of time up front. But then downstream, you're going to get a lot of benefits from that. But the biggest problem is that if your database develops or changes, and it is bound to change because your product is developing, it's not carved in stone. If the database is changed in a major way, then you'll have to rebuild your mock database. But on the other hand, if you have agreed, if you talked this over with the database developer beforehand, then you're not going to have this problem anymore. All right, we've figured out the database part. We have our data. We have the automatic deployment of data. We run our tests. The next point that you may have is the issue of test runs, because we may sometimes realize that our tests take 10 hours in a row. So the question is, how do we solve it? How do we deal with it? We have to run our tests in parallel. The most obvious thing, that of course is a bit tricky, but in fact, quite honestly, I'd like to say right away that there are quite a lot of tricky parts, but I will focus on the most serious ones. First of all, we have to be completely clear that our framework is stream-free, stream-safe. It's easier said than done. I mean, when it comes to correctly implementing it, all the test elements of our framework have to be initialized non-statically. If we're talking about UI tests, our WebDriver, that mustn't be static, so that its instance is never transferred from test to test. If we have a connect to a database during the testing, all of these components that are responsible for connecting to the database, so that we don't mix any data, each stream should have its instance. It mustn't be static. If we're testing services or APIs, so the component that sends or receives data must never be static. It should be secure. So please pay attention to these things before you do anything else, because when you get to parallelization, you may realize that you have to rewrite the entire framework. Regarding the non-critical component, there is always a holy war between people who think that the pages can be static and the others who don't think so. In 9% of the cases, yes, no matter how strange this may sound to you, page object is a stateless thing. This is stateless object. Our pages are stateless. It doesn't matter what the state of the application. We have our driver, which is going to be sending requests to these pages. The classes of the pages themselves may be static. There's no problem with parallelization. Yes, but in 99% of the cases, yes, sometimes you may have problems, but only in 1% of the cases. And the next thing has to do with test independence. I think we have discussed it to a certain extent. We have said that tests must be as independent as possible. If some tests adds data to the database, it has to work with its own data sets. The third, the one that deletes the data, has to do it. Unfortunately, sometimes this is not possible. For example, when we change some global settings of an application, for example, we have a test for admin settings. When we set a setting that affects the entire application regardless of who the user is. For example, there's a new tab, we added it when we were in admin, and then we removed it, and it disappears for all the other users who are not admins. So for these tests, we have to run these tests not in parallel. And in the majority of unit test frameworks, and I'm not saying that for all the tests, because I haven't worked with all of them, but when it comes to the ones that I have worked, you can switch off parallelization of tests. So technically, this is not hard to do. You can do this, but please remember that if you're going to run tests that may affect the entire functionality, you may not run them in parallel. The next thing that you've got to pay attention to in the context of parallel launch has to do with distributed test run. If we're talking about Selenium WebDriver, pay attention to such tools as Selenium Grid that allow on its own infrastructure, allows you to set up a distributed run. You can set up a hub or separate hubs on which the tests will run. There's another great project called Selenium. Under the hood, it uses the same grid, but it uses containerization. But otherwise, things are pretty simple, easy to deploy. You don't have to reinvent the wheel. And there are lots of cloud platforms that allow you to run tests in a distributed fashion. If you don't want to set up your infrastructure on your side, you can pay a certain amount of money and use the services, the capabilities of cloud services. You can use preset nodes with any operating system, with any browser, with any settings. You just pay the money and you run your tests on that infrastructure. The next thing we pay attention to is when we're talking about implementing CI tests is reporting, especially. Why is it so important in the context of CI? Because when we run our tests regularly, we need to be able to easily analyze the results of those tests, even if it's not just trivial bus fail rate. It's not enough to see how many tests failed, how many tests were passed. If your reporting allows you to easily understand why certain tests failed, that's a very good thing. So the question is, how do you get that functionality? Why do we need this reporting? Very good reporting. When we try to look at a stack trace, if we run our tests in parallel, in this set of lines indicating which steps were performed, it's very good that if you have a logger, but if you run these tests in parallel, all of them will be shuffled together, and it's going to be very hard to figure things out. If you don't have any standard unit test reporters, even these standard reporters are not as powerful they don't provide as much information as you would need. It's good if you have, let's say, 50 tests. It's not a problem to run through all of these tests. If you have several thousand tests, it's very difficult to understand why certain tests failed in that pipeline. So one of the key points when you choose a reporting instrument tool is the transparency and readability that it provides into the results of those tests. And the second parameter that you need to take into account is the customizability. If you just have some HTML reports with static information, if it's just it, please don't go for it. That's not very good. That's not a very good thing. If your instrument, if your tool allows you to customize things, especially after you've run the tests, you have the reports, if you can make changes to it, if you can make, let's say, notes, for example, to be able to run that, okay, this test failed for this and this reason. If you can easily trace errors in certain, if you can, for example, if your reporting instrument allows you to see why certain failed in a certain stack, that's good. If you can, let's say, make a note that this product or this test failed because of a product bug, that's great. You can get back at any point in the future to this report and see that this was a product bug, and you can just skip through it without racking your brain trying to understand why the heck the test failed. So if you can create additional dashboards showing some additional statistics, that's another great feature you want to have, because that would allow you to see how the statistics evolves over time. You can see the dynamics, and I'm getting ahead of myself a little bit. So the next thing related to reports is shared access to your reporting, because well, it's a no-brainer. If you just store some HTML file in one place, you have to send it via email. It's not clear how people are going to analyze them. Perhaps people will run their own documents with notes. It's easier to have one shared access, one shared reporting result. And by the way, many tools, in fact, provide this functionality. Please pay attention to them first. Give them priority, because reporting is really an important tool. And let's go back to the question of tracing dynamics. The same graph, but sliced and diced in a different way. And if you look at this, if you see this, there's something wrong with your test. It's not clear immediately what is wrong, but it means that you have to act immediately to fix it. And also, you can monitor the dynamics of one single test. And by the way, screenshots of reporting portal, probably you have recognized this screenshot. It's this great tool. And forgive me this plug. Our product is open, you can use it. By the way, it's great. You can monitor the dynamics for a selected single test. For example, you can select a test and you can see what its behavior was. At a certain point, you see that the test failed. You can open up and take a look at the stack trace and get an idea why the test failed. If the test is unstable, either it fails or it doesn't fail, perhaps you can make a guess that there's something's wrong with the stack itself. So this is a very powerful instrument which allows you to identify what kind of problems there are with the tests. All right, we've figured out the reporting part. Okay, we run our tests at regular intervals. We look at the results, we analyze them. If the tests are right, we integrate them back, we launch them again. But all of that kind of happens in one separate sandbox. The next test, and if things get that far, related to the creating your own pipeline. So this is kind of a set of builds, including the unit test block, application test block, and automated test automated UI test block. And I define a block as a stage or a phase in which our application is redeployed to a new UI. So in other words, each set of tests runs on its own UI, new UI. Overall, there are two major approaches to the creation of pipelines, and by the way, none of them is right or wrong. They're just implemented in different ways. The first classic approach is when you assemble or you build an application, run unit tests, and it's good for the developer to first run the tests locally, and then you merge to master this branch, and then you run the tests again. After the unit tests, the application is redeployed to a new environment where the next series of tests are launched, integration tests. They can be on the level of service tests, and they can also be on the level of inter-application services. If your architecture is not service-oriented, is not service-centric, then you can do it differently. And another popular trend is a multi-step or three-step pipeline. When we assemble unit tests, we deploy, then we do service tests, and we deploy, and then we go to E2E, end-to-end tests. But the question you want to ask here is that, remember we said the whole CI cycle should only take 10 minutes. And by the way, I only have 10 minutes to go, which is symbolic. But it's impossible to do. No matter how you parallelize the whole thing, you're not going to stuff it into a 10-minute period. So UI end-to-end scenarios don't have to be run in every deploy and every build, because for every new code you run all our tests, that would mean that the developer will spend most of his or her working time doing tests, which is not good. So we do it differently. We'll launch our unit tests, we run them, we redeploy, we do all the CPI tests, and if the tests fail, we don't move to the next phase. Then we run the tests again, we deploy things successfully, and the developer may assume that his or her work is done. But then, during the day, we launch our unit tests, assuming that these tests will be over by the end of the working day. Then the developer can move to the next tests. Our end-to-end tests are being executed. But what do we do if we identify a problem? Okay, which of you recognizes this guy? This bug. This is the first officially found bug. Bug, by the way, that was the kind of the genesis of the term bug. I think that was back in 1947 or something. Oh, this story goes as follows. A bug got on the light bulb. The light bulb stopped working. Then the computer went down, and that's how the term computer bug appeared. But the term bug, in fact, just to be completely honest with you, had existed before. Now this document is now kept in one American museum, but that was just an aside remark. So if our test finds a problem during the test, during the test run, then we assign a high priority to this bug, and the developer tries to fix it as soon as possible. After the fix is found, ideally, all the unit tests are run locally. Local integration tests are run, and then also this one test that had identified the bug is also run. Ideally, the picture looks that way. After all of this, the branches merged, and then we run our CI tests automatically. We launched application-wide API tests and all the others, and on the next day we run our UI tests. So that's the ideal test. So that allows us to shorten the time it takes us to be completely sure that the application works, and in our master branch we have a production grade application and the code that works. At this point we may relax and continue work normally. But I'm not going to stop here. I know that I'm running out of time. What other things should we care about? We have discussed the fact that the developer should be able to run just one test that found the defect or the bug in order to verify the entire test. There's no point running the entire set of tests. All of the tests will be run tomorrow. But the developer must run this very important test in order to see that the bug has been fixed. And in our framework, we need to look at the parameterization of everything, all the way down to running one unit test. Speaking about Java, and I'm going to divert a little bit from the main topic. The big benefit is given by TestNG framework. Perhaps I'm a little bit, I don't have up-to-date information, but that tool allows you to run package, an entire package of tests. So perhaps things have changed, but I haven't heard about it. TestNG allows you to run one single test. And then we configure the environment through command line in order to know in which environment the tests will run. Of course, the tester will need to be able to set in which environment the tests will run, and this must be, there needs to be the possibility to set this through the command line. So the more things you can parameterize through the terminal, the better it is. And by the way, you also need to set all the configurations on the server. Let me also tell you another tangential story. All your tests can be assembled on different platforms and run on those different platforms. It may not be particularly relevant to you because you may be kind of focused on one single platform, let's say Windows or Linux. You don't care about this cross-platform interrupt. But if you have an application written on Java, your tests are written on Java, please think about this cross-platform interoperability. And I'm going to tell you a story that I had to deal with recently. I had to work with a framework that had been written before we got on the project, when we had to kind of improve it, and through some manipulation it used a tool called AutoEat. So what it does is it controls a Windows operating system. AutoEat's scripts compiled into exe files, and these exe files only work under Windows, not on any other operating system. So our job was to get these scripts to work in other operating systems and other platforms. So please remember that if your CI is going to run under Linux, if you use, let's say, Windows-oriented tool, you're not going to do anything at all The next question: how do you figure out how many N's you have? I know that I have run out of my time very quickly. Well, roughly for each test you should have one environment. For unit tests you have one environment, for integration tests you have another, and for UI tests still another. So, the summary. To get involved in CI process, especially if you write UI and auto tests, we have discussed how this can be done, how to make things. Well, divide tests into different layers. You may have UI tests, a specific layer for integration tests, end-to-end tests, and UI tests. Don't forget about the fact that you are going to parameterize your tests at a certain point, because when you integrate into CI, you're going to settle a lot of parameters and dependencies through the terminal or CMD. Think about how to ensure that your tests can be assembled on different platforms. Think about it in advance and pay attention to test reporting, so that your reports are easy to read, are easy to understand, and easy to get insights from. Please also use environments wisely. You don't want to have 50 different environments, but ideally you should have one environment per test. And now I'm ready to take your question. Okay, let's give a big round of applause to our speaker. We have lots of questions in Slido. We're going to show them to you now. I think we have 5 minutes. So let's jump right in. Okay, while we're getting the Slido questions on the screen, are there any brave people who are ready to shout out their questions from the audience? No? All right. There is a guy over there. Hi. Did I get you right that the best way of preparing data is mock datasets? Well, I'd like to repeat that each of these options have their benefits and shortcomings, but perhaps the mock-up is kind of an advanced option. So you have to come to it. You have to get mature yourself enough to be able to use it productively. And a follow-up question. Can we use this pipeline to create test data? In the pipeline, well, your application is deployed in the pipeline. In your pipeline, you set how your application is deployed, in which environment. So your mock database can be deployed at a point that is after all the tests are done, and so on and so forth. So we use the tests, we use the environments that we use for API tests, UI tests, and CI tests. This database is deployed to this particular env. That makes sense if you work in the pipeline. Thank you.
Vadim, please use your iPad because there is some technical error. Question 1, tricky one. Reporting tools that you use apart from iPort portal, and why? I had a rich experience with a Yandex tool called Allure. It was a powerful tool which was quite a hype, and it inspired us to build a report portal, because initially we wanted to develop Allure something better than Allure. It's good, but it lacked a lot of things. Now Allure is a bit lagging behind. It's behind the report portal, quite close to it, but not as good as the portal. The main thing of report portal is that it has auto analysis of bugs, which enables us, on the basis of what kind of statuses you applied, on the basis of machine learning, it learns to correct the same tests, the same bugs, and it understands that this is a product bug. It does it automatically. It has to be taught for a long time. Machine learning takes time. The more data you feed in, the better it works. And analysis of defects, of test failures can be automated sooner or later. Actually, a lot of customization of reports is there, a lot of useful things. So two main tools, Allure and Report Portal. I like Report Portal more, not because I work in that company, but because it's more powerful and better customized. You don't need it everywhere. If you have a project for 50 auto tests, that is superficial. If it is quite serious, thousands of regular tests, then this is a magic wand for you. One question, even two: how to develop auto test without APIs? And well, actually, if you don't have any announcement about entering your data into the database, you cannot do that. If it's a copy of the production database, it has to be kept in a certain status, and you are not allowed to write everything you need. There are three options. One of them, UICon. Despite the fact that I said that this is bad, there is no right way, there is no wrong way. If you don't have any other way, generate data in the process of auto test. Even use UI. Better use UI other than doing nothing. It's better than do nothing. Last question. Of course, you can go to Vadim and ask your questions individually, because we don't have any time. We shall split into three groups. Last question, please. How do you combine full cycle of continuous integration with automatic tests? Oh, yes. Well, actually, we run full set of unit tests, then full set of API tests, and then UI tests. This can be a full regression test. If it goes on within reasonable time, within several hours, it can be integrated in the way I told you. You run tests once a day. If you find effects, you track them, fix them, rerun, full cycle of unit tests, quick API tests, and one final bug test. This is beyond full regression. You cannot run full regression every day, but if you have appropriate resources, why not? If your tests are physically run for 15 to 20 hours, then do it rarely, but maybe not once a day, once 2 days, 3 days, once a week if you can, but run them. You don't need full regression all the time. Sanity tests, small tests, some test sets reduced sets which allow you to check critical functionality. Run them once a day and full regression once a week. There are different approaches, so the more often you do it, the better. Thank you very much indeed.